Hey everyone, welcome. Today we're going to talk about a piece of medical technology that is frankly incredible. We're going to see how doctors can get a perfectly clear picture of one of the trickiest subjects you could possibly imagine, the human heart, which, as you know, is always on the move. It really all starts with this one simple question. It's a question you've probably asked yourself if you've ever tried to take a photo of, say, a running kid or a pet. How in the world do you get a sharp, clear picture of something that just will not stay still? This was the massive challenge for doctors trying to get a good look inside the heart. And here's the thing, it's not just that the heart is moving. It's also sitting inside our chests at this really complex kind of tilted angle. It's not neatly straight up and down or side to side, and that little detail makes getting a good, straight-on view a whole lot harder. So you've got this constant motion from the heartbeat, and you've got blood literally pulsing through its chambers. All of that movement creates something called motion artifacts. It's just like trying to take a photo of a car speeding down the highway at night. You know what you get? A blurry, streaky mess, which is completely useless if you're a doctor trying to figure out what's wrong. But there is a solution, and it's a seriously powerful one. This is where cardiac MRI, or CMR as they call it, enters the story. So what exactly is it? Well, cardiac MRI is a non-invasive way for doctors to get this incredibly detailed look at the heart's structure and, just as importantly, how well it's actually working. It's often called a one-stop shop for checking out the heart, just because it gives you the whole picture. And when you put it side by side with other tech, like a cardiac CT scan, the perks really stand out. First and biggest one, an MRI is radiation-free. It uses powerful magnets instead. It also gives a much sharper picture of the heart's tissues, which makes it way easier to tell healthy muscle from, say, scar tissue. And on top of all that, it often doesn't even require injecting contrast dyes into the patient. In fact, its ability to show so much detail has earned it this really impressive title in the medical world, the gold standard. When doctors need the absolute best, safest, and clearest understanding of the heart, this is the tool they turn to. All right, so we've established it's the gold standard, but how does it actually do it? How does this amazing technology solve that seemingly impossible problem of imaging a target that's always moving? Well, the technique they came up with is nothing short of brilliant. The secret sauce is a technique called cardiac gating. The best way to think about it is like a perfectly synchronized conversation between the patient's heart and the MRI scanner. The heart basically gives the scanner a signal, telling it the exact perfect millisecond to snap a picture. It's actually a pretty logical process. First, they stick a few ECG electrodes on the patient's chest. These are just listening in, picking up the heart's electrical signal. Then, the system is programmed to look for one very specific part of that signal, the R-Wave. That's the biggest, sharpest spike you see on an ECG, and it marks the powerful squeeze of the heart's main chambers. And then, here's the magic, the very peak of that R-wave acts as a trigger, telling the scanner, now, take the shot. And here's why that's so clever. The scanner takes one slice of the image at that precise moment. Then it waits for the next heartbeat, finds that R-wave again, and takes another picture at the exact same point in the cycle. It does this over and over and over again. Then it stitches all those perfectly timed snapshots together to create one final composite image that looks like the heart was holding perfectly still the whole time. Just brilliant. Okay, so we figured out how to freeze the heart in time, which is amazing. But now what? What kind of pictures can doctors actually get from this? This is where we get into the idea of slicing. The best analogy for this is to picture an apple. You could slice it from top to bottom, you could slice it from side to side, or you could cut it right through the middle to see the core. Each slice gives you a totally different view, right? Well, doctors do the exact same thing with the heart. They create images along these different planes to see it from every possible angle. And each of these different slices gives a unique and vital perspective. The long axis views can show the heart lengthwise, which is great for checking out the front and back walls. Then there's the famous four-chamber view, which, the name says it all, right? It gives you a perfect look at all four chambers working together. And the short axis view is like looking at slices of a loaf of bread, giving you these great cross-sections to check the thickness and strength of the heart's main pumping muscles. So let's tie all of this incredible tech back to why it's so important in the real world. Why go through all of this? Well, it's all about diagnosing and managing real, life-affecting medical conditions. And this list really shows you why this matters so much. Cardiac MRI is absolutely crucial for doctors. They use it to see the damage from a heart attack, to diagnose heart failure, to find tumors or masses on the heart, and even to plan surgeries for complex heart defects that babies are born with. The list just goes on and on. So at the end of the day, what cardiac MRI really gives us is this complete, safe, and totally non-invasive window right into the heart. It's so much more than just a picture. It's a deep dive into the heart's structure, its function, the flow of blood, and even the health of the muscle tissue itself, letting doctors see things like scarring from an old injury. And that really just leaves us with a pretty fascinating thought to end on. This technology already lets us see the heart in ways that were pure science fiction not that long ago. So as it keeps getting better, faster, and even more detailed, you just have to wonder, what new mysteries of the human heart are we going to unlock next?